In this lesson, we're going to create inequalities and solve them that represent real-world situations. So our first little bit of review is going to be our symbols, our inequality symbols. And an inequality is a statement that compares two expressions that are not strictly equal by using one of the following symbols. We have our less than symbol. We have less than or equal to. We have greater than. Greater than or equal to. And then we have not equal. And verbal descriptions include words like the same as. That would be equal to. But when we're dealing with inequalities, we have to understand must be at least. So at least would be an inequality. Another type of no more than. Those are examples of inequality verbal descriptions. We'll be taking those and translating them using the algebraic symbol or the mathematical symbol. So here's an example. Nora's planning a birthday party for her little sister, Colleen. Nora's budget will allow her to spend no more than $50 for party supplies. So that means that she can spend up to $50. She can spend less than $50, but she cannot exceed $50. 8 children, including Colleen, will attend the party. Nora wants to determine how much she could spend on party favors for each child. She will also purchase a cake for $10. Write an inequality that represents the situation and find possible solutions. So we have $50 to spend, but no more than that. So we're going to start with $50, and that $50 is going to be the absolute max. We can spend exactly $50 or what we spend. So these are our expenditures, must be less than or equal to 50. Now she has to buy a cake for $10 and she wants party favors for each child. So we have party favors for 8. We also have the cake that costs $10 that we have to add together here. Well, the cake cost is $10. The party favors, we don't know how much each party favor costs. So we're going to say X equals the cost for each party favor. So we'll take 8 times X plus 10 is less than or equal to 50. So here's our party favor cost, our cake cost, add that together, and it needs to be less than or equal to 50. Now we're going to solve the inequality by subtracting 10 from both sides. That gives us 8x is less than or equal to 40. We're going to divide both sides by 8. And x is less than or equal to 5, meaning that each party favor can cost $5 or less. So on a number line, we have $5. To the right on the number line, we would have 6, and to the left, we would have 4. And we can pick party favors that are $5 or less. So the solution graphically looks like this green solution set as an inequality, x is less than or equal to 5. Now, creating and solving inequalities involving the distributive property, sometimes that involves dividing by a negative. And when we divide by a negative, we have to flip the inequality symbol. So this is very important here. The inequality symbol or sign must be reversed when multiplying or dividing both sides of an inequality by a negative number. So here's an example. If I have negative 2x is greater than or equal to 18. In order to solve this inequality, I have to divide both sides by negative 2. When I divide both sides by that negative number, I have to reverse the inequality sign or symbol. So instead of x is greater than or equal to, I have x is less than or equal to. And then 18 divided by negative 2 is negative 9. Graphically, to the left of negative 9 is negative 10, and to the right of negative 9 is negative 8. We go to positive infinity on the right, negative infinity on the left. We're used to saying negative 9 is included because of the equal to, and then x is less than negative 9 would shade towards the left, towards negative infinity. However, in Algebra 1, the closed dot now becomes a bracket. And from this red graphical representation, we can write interval notation. So interval notation in Algebra 1 and higher is always written from left to right. On the left, we have negative infinity. And on the right, the graph ends at negative 9. Now, negative 9 is included, so it has a bracket. Negative infinity is not a number, it's an idea. So we can never close in on negative infinity, so it is a parenthesis. Open circles or values not included are exchanged for parentheses in Algebra 1 and higher. So no more open circles. Closed circles showing that values are included are exchanged for brackets. And brackets signify a closed interval, meaning a closed circle or an included value. Since negative 9 is included, we'll use a bracket to close in on negative 9. Since negative infinity is not a value that we can close in on because it's not a value, we use a parenthesis. So we'll practice using let's practice. I'm going to go to this example right here. We're going to practice with these inequalities right here. We have 4/3 times the quantity 6x plus 9 is less than 4. Now on the left-hand side of the inequality, I have one term connected by multiplication, and the right-hand side, I have one term. I'm going to multiply both sides by 3 to get rid of the denominator, and I have 4 times 6x plus 9 is less than 12. Now I'm going to divide both sides by 4. And the reason I'm doing that is because 12 is divisible by 4. It's 3. We're going to subtract 9 from both sides. 6x is less than negative 6. And now I'm going to divide both sides by a positive 6. So my inequality symbol does not change, and I get x is less than negative 1. On a number line, to the left of negative 1, I have negative 2. And the arrow on the left goes to negative infinity. On the right of negative 1, I have 0. And that arrow goes to positive infinity on the right. Negative 1 is not included, so we would normally have an open circle. X is less than negative 1, so we would shade to the left, where all of these values would make this inequality true. In interval notation, we reproduce this graphical representation from left to right. Negative infinity is on the left with this arrowhead, and on the right we stop at negative 1. Negative infinity always has a parenthesis, and negative 1, because it is not included, is a parenthesis. Okay, here's another example. We have negative 2 times the quantity. 1/4 x plus 2 is greater than or equal to 5. Now I'm going to distribute the negative 2 because dividing both sides would leave me with a fraction on the right hand side, and I'd prefer not to do that. Negative 2 times 1/4 x is the same thing as negative 2/4 x, which is negative 1/2 x. So negative 1/2 x, negative 2 times positive 2 is negative 4, is greater than or equal to 5. I'm going to add 4 to both sides of the inequality, and I get negative 1/2 x is greater than or equal to 9. I'm going to multiply both sides by negative 2. The negative, so that the negative times the negative is a positive, and the 2 so that they cancel out. That's going to give me x, because a negative times a negative is a positive 1. But because I multiplied by negative 2, I have to flip my symbol and make it less than or equal to negative 18. Graphically, we have negative 19 to the left of negative 18. The arrow goes to negative infinity. To the right of negative 18, I have negative 17. and that arrow on the right goes to positive infinity, negative 18 is included because of the equal to sign, so I close the circle. Less than, again, shades to the left. And our interval notation starts at negative infinity, as that's what the arrow symbolizes. And then our dot is at negative 18. So the left end goes to negative infinity with a parenthesis, because negative infinity always has a parenthesis, never a bracket. And negative 18, because of the closed circle, is a bracket. So there's our interval notation. Here we have our graphical representation. And here we have our inequality representation. So all three of these solutions, the inequality, the graph, and the interval notation, those are three different ways to show the solution to the inequality.